So today we are going to talk about composite areas, today and tomorrow. Composite areas are where you take two or more shapes and you put them together. Sometimes you're going to take these shapes and put them together like it looks like here in A or B, and sometimes we're going to be cutting a hole out of another shape. So the first thing I want to do on a composite area problem is determine which shapes I have and whether I would be adding areas together or subtracting things. On example A, what are the shapes that we have here? What is this made up of? A square, a hexagon, yep, and a trapezoid. That's absolutely correct. Are any of those holes that have been cut out of another piece? No. So we're going to add their areas together. If we have a hole, then we would be taking it away. We would be subtracting it. So we need the area of the square, bless you, plus the area of the hexagon, plus the area of the trapezoid. So first, the area for the square. How do you find the area of a square? Length times width, but what do you know about the length and the width on a square? They're congruent, they're both the same. So on this hexagon, this 9 centimeters right here that's in the center, oops, that's telling me that each of these sides is 9 centimeters. So from here to here is 9 centimeters, which means since this is a square across the top, that would also be 9 centimeters. So for the area of my square, we have 9 squared, which should be 81 square centimeters. And then we need the area of the hexagon. What do we need if we're going to find the area of the hexagon? What do we need if we're going to find the area of a hexagon? Well, we had a whole category of shapes that we learned about last week called regular polygons. A hexagon is a type of a regular polygon. How do we find the area of a regular polygon? A times P. Yep, 1/2 A apothem times perimeter, because it's a lowercase a, that's what we use to find the area. So we would do 1/2 apothem times perimeter. We could also do 1/2 AB sine C times the number of sides times n. We would do 1/2 AB sine C times the number of sides when we know the radius, but we don't know the radius of this hexagon. Do we have the ability to find the perimeter of the hexagon? Yes. All the sides on that hexagon are how big? 9. All the sides on the hexagon are 9 centimeters long. So the the perimeter for the hexagon, we have 6 sides, 9 centimeters for each side. So the perimeter of the hexagon would be 54 centimeters. But now we need the apothem. We need the apothem. I'm going to redraw just the hexagon off to the side over here. All right, there's my redrawing of the hexagon. So the apothem goes from the center straight down to the side, and where it hits the side, it makes a right angle. So I'm going to come in and I'm going to draw in a radius. I know across the bottom is how big? What is the side length of the hexagon? 9 centimeters. So how much would half of that be? Half of 9 is 3? 4.5. Half of 9 is 4.5. So that's 4.5 centimeters. The central angle would be this angle right here. The angle that I want is half of that. So we do the measurement for the central angle, which is 360 divided by the number of sides. What is 360 divided by 6? 60. And then we're going to take that 60, and we're going to cut that in half. So 30 degrees. This angle right here is 30 degrees. I'm looking at this little triangle here. We want to find the apothem, which is this piece right here. If I stand up at this 30-degree angle, where's the hypotenuse in that? If we stand at the 30-degree angle, where is the hypotenuse? Nope, 4.5 is not the hypotenuse. The one across from the right angle, the radius. This would be the hypotenuse, and so the 4.5 would be opposite or adjacent? Opposite. And so the apothem that we are looking for is the adjacent side. So we have the opposite side, we want the adjacent side. Which function would we need to use to find the adjacent side then? Sine, cosine, or tangent? Cosine would be adjacent and hypotenuse. Do we know the hypotenuse? No. But you're right, we want the one with the adjacent side. So let's write down SOHCAHTOA. Maybe an easier way, if we're looking at SOHCAHTOA, is to say which side do we not know and we don't care about. Yeah, the side that we don't know and don't care about is the hypotenuse in this example. So we're going to use tangent. So we would have tangent of our angle, which is 30 degrees, is equal to the opposite, 4.5, over the adjacent, which is my apothem. We're going to multiply both sides by the adjacent side. Cancels out over here on the right. So then I have adjacent times the tangent of 30 degrees equals 4.5. And then we divide both sides by the tangent of 30 degrees. And that will give me my adjacent side. We have 4.5 divided by the tangent of 30 degrees. You are going to need a calculator to do this, so please go and grab a yellow calculator if you do not have one of your own to use at your desk. What do we get when we do 4.5 divided by the tangent of 30 degrees? 7.794. That's absolutely correct. And again, this is the apothem. So to find the area of the hexagon, we do 1/2 times 7.794 times the perimeter, which was 54. And what do we get? Let me look at your calculator real quick. I couldn't hear super well. There we go. Okay. That's you said it right. I just heard it right, or heard it incorrectly. My apologies. 210.438. That's absolutely correct. That would be centimeters squared. So we have just the area of the square, we have just the area of the hexagon, and now we need the area of the trapezoid. Area for a trapezoid is 1/2 height times base 1 plus base 2. And the height is the distance between the bases. My bases on this trapezoid are this side right here and this side right here. I see that this side, this base, is 15 centimeters, so we're going to call that base 2. How big is the other base, this one over here? 9 centimeters, so we'll call that base 1. What's the distance between those bases? 19 centimeters. That is the height of the trapezoid. I know it's not standing upright, but the height is always going to be the distance between the bases. So 1/2 times 19 times base 1, which is 9, plus base 2, which is 15. So we do 1/2 times 19 times 9 plus 15. And what do we get? $228. 228 centimeters squared. All right, so now we have the areas of all three parts. So we need to take the 81 centimeters squared. We're going to add that to the 210.438 centimeters squared. We're going to add that to the 228 centimeters squared. So 81 plus 210.438 plus 228. What do we get when we add all of that together? $519.438 centimeters squared. All right. That was a good bit of work. Let's try another one. What are the shapes that make up example B? A triangle, so we're going to need the area of the triangle. Plus what? A rectangle. So area of a triangle plus area of the rectangle plus, are there any more shapes? The five-sided shape, the pentagon. So area of the triangle plus area of the rectangle plus area of the pentagon. So let's do area of the triangle first. Area of a triangle, we can do 1/2 AB sine C, or we can do 1/2 base times height, which I think we're going to be able to do here. Here's my triangle. These two sides right here would have to be the base and the height, because together they make a right angle. And I always want to be looking for that right angle when I'm looking for the height of a triangle, because two of the sides come together to make that right angle. One of them is the base and one of them is the height. I know how big this side is. How big is that? 3. This is 3 yards, but we're going to need to find this side over here. Because of that right angle, I know it's a right triangle, which means I could use what to find that side? Pythagorean theorem. A squared plus b squared equals c squared. What part of the right triangle has to go in for c? The hypotenuse. What's the hypotenuse of this right triangle? 5. So we're going to have 5 squared. 3 goes in for either A or B. I'm going to put it in for B. And so then A we will just leave as A. So I would have A squared plus 9 equals 25. And we're going to have to subtract 9 from both sides. What is 25 minus 9? 16. So I have A squared equals 16. Then to get the A all by itself, we're going to take a square root of both sides. The squared and the square root cancel each other out over on the left. And that means A is what? A is 4. It's a 3, 4, 5 triangle. That's a Pythagorean triple, yes. All right, so to find the area of the triangle, we do 1/2, and then the base and the height are the 3 and the 4. One of them is the base, one of them is the height, and it doesn't matter which is which. What is 1/2 times 3 times 4? 6. So this would be 6 yards squared. All right. Now we need the area of the rectangle. Length times width. What is the length of the rectangle? 8 is the length of the rectangle. What is the width of the rectangle? 3. And 8 times 3 would give us what? 24. So 24 yards squared. And that just leaves our pentagon now. A pentagon is another type of regular polygon. So 1/2 apothem times perimeter. How big are each of the sides of this pentagon? 3. So we can do perimeter for the pentagon. Number of sides, 5 times the length of each side, which would be 3. So 15 yards for the perimeter. And then we need the apothem. So I'm going to draw this pentagon. The apothem goes from the center straight down to the side. Makes a right angle when it gets to the side. I'm going to go ahead and draw in 2 radii as well, because we need that half the central angle. And also, while I'm here, if each side of the pentagon is 3, how big is this half right here? 1.5. 1.5 yards. All right, so the measurement of the central angle now. We do 360 degrees divided by the number of sides. So divided by 5. What is 360 divided by 5? 72. So then we take that 72 degrees and we cut that in half. That would give me 36 degrees. So this angle right here is 36 degrees. Just like last time, we're going to label up our sides. The radius is the hypotenuse. The 1.5 yards is my opposite side. And the apothem here is the adjacent side. So, ka, toa. Which side do we not know and we don't care that we don't know? Hypotenuse. So no sine, no cosine. Has to be tangent again. So we would have tangent of 36 degrees equals opposite, which is 1.5, over adjacent. Running out of room here. I'm going to have to bring my work down here, I think. Tangent of 36 degrees equals 1.5 over adjacent. What would I need to do now? Multiply by the adjacent side on both sides, yes. It's going to cancel out my adjacent side over there on the right. So then I would have adjacent times tangent of 36 degrees equals 1.5. Now what do I do? Divide. We're going to divide by the tangent of 36 degrees. Cancels out over on the left. And how big is our adjacent side then? 2.064, yes. This is the apothem. So in the area of my pentagon, we have 1/2 times 2.064 times the perimeter of 15. What is 1/2 times 2.064 times 15? $15.484. 15.484 yards squared. So now we're going to take the area of the triangle, which was 6 yards squared, the area of the rectangle, which was 24 yards squared, And the area of the pentagon, which was 15.484 yards squared, we're going to add those together to get our composite area. 6 plus 24 plus 15.484. What do we get for our composite area? How much? 45.484. Yards squared. There's our composite area. All right. I'm going to go look at example C next. All right. Example C. I've got a couple of different shapes here. This one looks weird. Do we have a name for a shape that has this L appearance to it? So I'm going to have to cut this into shapes that I do know the names of. If I don't know the name of a shape, then I have to cut it down until I do know the names of the shapes. So if I were to cut this right here, what would we call this? That's a rectangle. And this? Trapezoid. What about this? Semicircle, yes. It's a semicircle. Okay, so we're going to need the area of the trapezoid plus the area of the rectangle plus the area of the semicircle. For trapezoids, we have 1/2 height times base 1 plus base 2. So I know one of my bases is 7 inches, right here. We'll call that base 1. Base 2 is not 15 inches. 15 inches goes from here all the way over here. It includes the side of the rectangle. How big is this right here? 5. We look at the other side of the rectangle. That much is 5. So how big is the base on my trapezoid? 10. That's going to be base 2. Then I still need the height. That's what's represented by this red line right here. That's the distance between the bases. How long is the side of the rectangle? 10 inches. And it shows me right here that this much of it is 6. Well, if from here to here is 10, and from here to here is 6, how big is this? 4. So this is 4 inches. All right, that's everything I need to find the area of my trapezoid. 1/2 times 4 times base 1, which is 7, plus base 2, which is 10. What is the area of our trapezoid? $34. 34 inches squared. Then we have the area for the rectangle. That's length times width. What are the length and the width of the rectangle? Five and 10. And so the area of the rectangle would be what? 50 inches squared, yes. All right. We need to find now the area of the semicircle. The area for a whole circle is pi r squared, so this is 1/2 pi r squared. I know the diameter from here over to here is 5 inches. The radius is equal to the diameter divided by 2. So 5 divided by 2, or 2.5. So for the area of the semicircle, we have 1/2 times pi times 2.5 squared. What is 1/2 times pi times 2.5 squared? $9.817. So now we're going to take the area of the trapezoid, which is 34, the area of the rectangle, which is 50, and the area of the semicircle, which is 9.817, and we're going to add all of those together. So 34 plus 50 plus 9.817 would be equal to what? 93.817 inches squared. Here's our composite area. All right. Looking at D. Do we have a name for that shape as it is? No. I don't have a name for that shape. Could I chop this into shapes that I do know the names of? Yes, where could I make a cut? Kind of like this? Is that what you were saying? Or were you saying to go the other way like this? This one right here? Yep, we could cut it either of those ways. We can cut it vertically or horizontally here. So what shape do I have up on top then? Trapezoid. And on the bottom we have a rectangle. I know this entire side of the figure is 9 feet, but I know that this side of the rectangle is 6 feet. So I know this right here would be 6 feet. So how big is this? 3 feet. All right, there's another length that I need to figure out. Across the bottom of my rectangle, it says it's 10 feet. This much is 4 feet. So how big is this? 6 feet. Because 6 plus 4 gives me 10. All right. We need the area of the trapezoid. Plus the area of the rectangle. The area of the trapezoid is 1/2 height times base 1 plus base 2. The height of the trapezoid is the distance between the two bases. What is the distance between the two bases on this trapezoid? What is the distance between the two bases of the trapezoid? 6, yes. So I have 1/2 times 6 times, how big are the two bases of the trapezoid? How big are the two bases on the trapezoid? Not 10. This right here, it looks like the bottom, I know, but it's the distance between my bases. My bases on a trapezoid have to be parallel. So this right here would be one of the bases, and this over here would be the other base. 3 and 8, yes. So I have 1/2 times 6 times 3 plus 8, which would give us what? One half times 6 times 3 plus 8. $33. We have 33 feet squared. Make sure you have the parentheses around the 3 plus 8. Otherwise, it's going to do 1/2 times 6 times 3, and then it'll just add 8 on top of that. You have to make sure you've got it inside parentheses. All right, and then we need the area of the rectangle. Length times width. What are the length and the width of the rectangle? 10 and 6. 10 times 6 would give us 60. So 60 feet squared. We're going to take the 33 feet squared for the trapezoid, add it to the 60 feet squared for the rectangle. What do we get when we add 33 plus 60? 93 feet squared, yes, for our composite area. Nicely done. Very nicely done. So tomorrow we will look at when we cut holes out of figures. We will find the composite area when we have removed a hole from a figure. Homework is due Thursday, not Wednesday. Tomorrow is Wednesday, so you still have tonight and tomorrow to work on the homework. You can start to get started on the homework for any of the shapes that do not have holes, in addition to any of the area of irregular polygon problems that you were supposed to work on yesterday.